Good day, everyone. I am Grace Consulta, who will discuss about the reactions of amines. So the objectives of these, at the end of the discussion, students should be able to know the reactions of amines in addition to behaving as bases. Bases amines can be nucleophile. So reactions of amines. Due to the unshared electron pair, amines can be act as both bases and nucleophiles. So the chemical properties of amines are weak organic bases. They react with water, produce alkyl ammonium ions and hydroxide anion with an acid to produce alkyl ammonium salts. So alkyl ammonium salts are the name by changing amine to ammonium and adding the name of the negative ion to the end of the word. So I have four examples of the reactions of amines, the different reactions of amines. So amines are pretty reactive substance. When we talked about the reaction that amines like to undergo. So amines are organic bases and it derives from the ammonium and well well they have the amino group and amino acid. As you know, they are the building blocks proteins. So the reaction that we're going to talk about here lay the foundation for protein chemistry. And well, if amines organic bases, they means that they're most likely soluble in water if they're low molecular, and they're going to interact with that water molecule if the nitrogen bases so the nitrogen is basic, the proton from the water is going to protonate the nitrogen. And we get a positive charge in CH3 and H3 positive, and left behind is the OH negative, or the addition is the OH negative. If we were to test this reaction with pH paper, we'd find that it's basic because the presence of OH ion and because of the presence of the nitrogen too. So the second reaction also takes advantage of the fact that amines are bases. If they react with water, surely they can react with an acid. So here we've got an amine plus hydrochloric acid, which amine react to the hydrochloric acid. The proton from the acid is going to attach to the nitrogen. And we get the CH3 and H3 plus Cl minus. When we have a plus and minus, that reminds us the inorganic compounds, we can call this a salt. It's an amine salt. And so the third one. So let's look at the number 3. So amine salt, the product of an acid and an amine reaction, can be reversed. We can get that amine back from by adding a stronger base. So sodium and hydroxide and the amine are now competing for the proton sodium. So sodium hydroxide is a lot stronger base. It's going to take the proton back from the amine to form a sodium chloride, and we have the amine back. And reaction number 4, we're talking about the amide formation, and here's the amide functional group. It's a C double bond O with a nitrogen next door. So amides are very important proteins, or amides. They're polyamides. Polyamides, we need a reactive substance like this acid chloride. You can think of its carboxylic acid. To form an amide, we need a reactive substance like this acid chloride. You can think of it as a carboxylic acid. We've traded the OH4 as Cl to get this acid chloride. It's much more reactive substance, and it can react with the amines, and what happens is one of the hydrogen from the amine and the H or the Cl form HCl. So the nitrogen is now bonded to the C double bond O. As this occurs, then we have this amide structure. Reactions with acid. When reacted with acids, amines donate electrons to form ammonium salt. So aniline reacted with sulfuric acid. So the product of this is anilinium acid sulfate. The reactions of acid halides. So acid halides react with the amines to form substituted amides. So propanol chloride reacts to the methylamine. So the product of it is N-methyl propanamide, and it's a secondary amide. So aldehydes. Aldehydes and ketones react with primary amines to give a reaction product, carbinolamine, that dehydrates to yield aldimines and ketimines, Schiff bases. So the reaction of aldehydes and ketones with ammonia or primary amines form imine derivatives, so also known as Schiff bases. Carbon double bond nitrogen function. Water is eliminated in the reaction, which is acid catalyzed and reversible in the same sense as acetal formation. So the general structure of it for that is R1, R2, so carbon double bond and R3. They considered as a subclass of imines and being either secondary ketamines or secondary aldimines, and depending on their structure. So if you react with the secondary amine with aldehydes, ketones in amines form. So cyclohexene, so amine reacted as cyclohexene. Reaction with acid halides. Reaction with sulfonyl chloride. Amines react with sulfonyl chloride to produce a sulfoamides. A typical example is the reaction of the benzene sulfate chloride with amine. The Hinchberg test. The Hinchberg test, which can distinguish primary, secondary, and tertiary amines, is based upon a sulfonamide formation in the Hirschberg test. An amine is reacted with a benzene sulfonyl chloride. If a product forms, the amine is either a primary or secondary amine because tertiary amines do not form stable sulfonamides. If the sulfonamide that forms dissolve in aqueous sodium hydroxide solution, it is a primary amine. If the sulfonamide is insoluble in aqueous sodium hydroxide, it is a secondary amine. The sulfonamide of a primary amine is soluble in aqueous base because still possess an acidic hydrogen on the nitrogen, which can be lost to form a sodium salt. Oxidation. So although you can oxidize all the amines, only tertiary amines give easily isolated product. The oxidation of the tertiary amine leads to the formation of the amine oxide. Arylamines tend to be easy oxidized, with oxidation occurring on the amine group as well as in the ring. Reaction with nitrous acid. Nitrous acid is an unstable and must be prepared in the reaction solution by mixing sodium nitrate with acid. So the primary amines react with nitrous acid to yield a diazonium salt, which is highly unstable and degrades into a carbocation that is capable of reaction with any nucleophile in solution. Therefore, reacting primary amines with nitrous acid leads to a mixture of alcohol, alkenes, and alkyl halides. The primary, secondary, and tertiary amines, which is the primary aromatic amines, form a stable diazonium salt of 0 degree. The secondary is secondary aliphatic and aromatic amines form nitrosoamine without nitrous acid. So the tertiary amines react with a nitrous acid to form an nitrosoammonium compound. Reactions of aromatics, diazonium salt. Diazonium salt of aromatic amines are very useful as intermediate to other compounds because aromatic diazonium salt are only stable at very low temperatures, 0 degrees and below. Warming this salt initiates decomposition into highly reactive cations. These cations can also react with any anion present in solution to form a variety of compounds. So that's all for my part, and that's the reactions of amines.